Good morning. It's great to see you all. My name is Ram Pedibotla. I run the cloud business at AMD. And in this session, I want to walk through how you can do more with less when you adopt AMD's 7th gen instances. Let me first begin with a brief overview of AMD. At AMD, our mission is to drive high-performance computing. Whether it's end customer devices like PCs or game consoles, or the 5G networks that connect them, or the services that are delivered from cloud and enterprise data centers to those devices, AMD technology is everywhere. As we apply our mission to the data center, we've put together a broad portfolio of high-performance engines, the best of the breed in the industry. We have the best server CPU in AMD EPYC. Our Instinct accelerators help optimize with performance and efficiency for AI and HPC. Our DPUs and SmartNICs accelerate the infrastructure at cloud and enterprise data centers, and our leadership FPGA portfolio enables solutions across a broad spectrum of industries. Now, I know what you're thinking. Okay, AMD, great hardware products. What are you guys doing here? You know, AMD has been coming to reInvent for years, and we still get asked this question. And there's a very simple answer to that. The choice of the CPU matters when you pick your AWS EC2 instances. It actually matters a lot. And in fact, it matters today way more than it ever did. And why is that? One very simple reason. Since last year's reInvent, we've all come to realize the incredible potential that large language models and Gen AI can deliver to each of our businesses. This opportunity, though, it came so fast, it caught the IT departments and CIOs by surprise. So the AI opportunity came, but it didn't bring any budget with it. So every CIO in the industry is either building or refining their AI strategy as we speak. And a key part of that strategy is dealing with the challenge of how do you fund the AI initiatives within a reasonable budget envelope. And that's what I'm here to talk about, where you can take your high volume workloads on EC2, get double the performance by modernizing to AMD instances, drive significant cost savings, and use those savings to fund your AI initiatives. To put it in very simple and specific terms, it's a very straightforward formula. When you adopt AMD's 7th gen EC2 instances, you get double the application performance on average across the most popular workloads in the enterprise. Notice that I said on average and not up to. We're all fairly attuned to the performance marketing notion of up to based on a couple of data points. But this is not that. This is based on averaging across the workloads that people use day in and day out in the enterprise. And 2x the performance from previous generation is extremely significant. Now, what does that performance do? You're able to get your work done using fewer instances. In fact, your instance footprint can be 48% smaller when you adopt these new generation AMD instances. And that has very high business impact. 37% lower OpEx spend. So you modernize to AMD instances, you have a lower instance footprint, and you immediately save 37% of your cloud spend. But these savings are only available if you adopt AMD instances. That 37% is right there, waiting to be deployed to AI projects. For all of us who are struggling with budget constraints, this is our free lunch. Or better yet, to be the heroes that figure out how to run the core business in a more optimal way and fund new initiatives. This sounds too good to be true. Stay with me. I will walk through very specific benefits on very specific workloads and explain how and why AMD-based EPYC instances deliver that much performance and that much value to you. Now, this is literally the money slide. So let me kind of spend some time here to unpack the details. What I'm showing you here is results across a spectrum of popular enterprise workloads, nominally split into two tiers. The front end, or the application tier, and the back end and the data tier. Each of these boxes has two numbers. The first one is the performance advantage of deploying that workload on AMD M7A instance over M6I instance. And the second number is the economic value of that performance. So the answer to the so what question. One key point to make here, what I'm showing here is a representative set of workloads. These are the most popular workloads. But this set of performance gains and economic value applies to a broad spectrum of workloads that are deployed in the cloud. And the comparison points are 7th gen M7A instance that's based on AMD EPYC processor, and 6th generation M6I instance that's based on Intel's processor, specifically Ice Lake. So let's start with the first bucket there, Java performance. Java is the most popular application development platform in the enterprise. And Java performance is very critical for IT decision making. What we're showing here is a result of SpecJBB benchmark, which is a very standard way of measuring Java performance, and specifically the max JOPS metric, which basically means how many Java operations you can push through in a given amount of time. M7A instances have 60% higher performance than M6I instances. Just pause and let's think about that. It's same instance on both sides, you get 60% more performance. And what that means is you can get the same number of Java operations done in a smaller instance footprint, and that results in a 24% OpEx savings. So same instances on both sides, 60% higher performance on one, fewer instances, 24% reduction in cloud spend, which is very, very significant. Now let's look at the next bucket there, which is Nginx, which is a very popular web server, web front-end workload. The metric of measure here is the number of requests that are serviced per second. And the performance of M7A is 90% higher than M6I. And that translates to 36% reduction in OpEx when you do the compare between M7A and M6I. So again, 90% higher performance, fewer instances, and 36% lower cloud spend. The third bucket here is audio and video processing, and we're showing the results of FFmpeg, which is a popular benchmark to measure the number of frames that are processed in a given amount of time. And the performance of M7A is off the charts. It is 150% higher for M7A versus M6I, and that results in greater than 50% OpEx savings. So similar equation, very high performance, half the cloud spend. Now, if you turn to the data tier, we look at MySQL, which is a very popular database deployed everywhere in the cloud, and specifically the OLTP, the transaction processing aspect of MySQL. And the performance of M7A over M6I is 70% higher. So you can get that many more database transactions done in a given amount of time on M7A versus M6I. And that means your cloud OpEx reduces by 31%. So 70% higher performance, 31% reduction in cloud spend. To the right of that is when you have the data, you want to get insights from that data. So here we are showing performance of Microsoft SQL Server, another very popular database that's broadly deployed in the enterprise. And specifically the queries per hour, how many queries are handled by that instance with that database. And the performance here is again 70% higher on M7A versus M6I, and that results in 30% OpEx savings. So higher performance, lower cloud spend. And the last bucket here is in-memory databases. Redis is a very popular NoSQL in-memory database, and the performance of M7A is 2.4x that of M6I. And that results in almost half your cloud spend being reduced. So 2.4x performance, again, fewer instances, that results in lower cloud spend, about 50%. Now, if you pause and take stock of this, across these workloads, all we did is average the performance across the workloads. You get 2x the performance on M7A versus M6I. These are workloads that you know and love and deploy every day. And that performance translates to 37% cost savings. And these savings are only available when you deploy with AMD-based 7th gen instances. When you think about what this kind of economic value can do for you, it immediately turbocharges the capability for you to do newer things and drive business transformation in your enterprise. Now let's double click into one of those. I want to go through the math that's behind what you've seen in the previous slide. So specifically looking at Nginx performance. So if you look in the middle, what we're showing here is performance on 4XL instance for M6I and M7A. So it's the same number of vCPUs on both sides. As you can see, M6I delivers 760,000 requests per second. M7A delivers almost 1.5 million, almost double the requests per second of M6I. Now, when you look at that performance delta between these two instances, it reflects very starkly on the top right. If you were putting together the infrastructure to deliver or to service 100 million requests per second, you would need 131 instances of M6I in order to deliver that kind of throughput. But you can get that exact same throughput with 70 M7A instances. So same amount of work done on both sides, almost half the instance footprint. Now, what does that mean in terms of the cost to serve, the cost to deliver those 100 million requests per second? You save 36% when you pick M7A versus M6I. That's the power of modernizing from M6I to M7A. And these savings are available only if you pick the AMD-based instances. Now, you could be thinking, well, hey, Intel has next-generation instances as well, so M7I. That could be a path for you to modernize from M6A. Head-to-head comparing M7I versus M7A, both of them the same generation. One is based on AMD 4th Gen EPYC, the other is based on Intel 4th Gen Xeon. M7A is 60% faster than M7I. So if you pick to modernize with M7I, you actually lose 80% of the savings I'm showing here. So at that point, you'd have to wonder, is that even modernizing? So if you want to modernize right, pick the instance that delivers the best technology, the best performance, that translates to extremely compelling cost savings for you. You know, in my career, I've never seen an economic value jump in one generation of this much magnitude. This is a phenomenal value that we've been able to bring to you with these new generation AWS instances. Now let me walk through a real-world scenario of what that performance and economic value means and what is the business impact of deploying the 7th-gen instances. In this scenario, let's say that you are the head of IT for a global e-commerce company, and you're hosting your infrastructure to drive your commerce engines on AWS EC2, and your infrastructure budget to do that is $14 million. That's kind of the scenario. And you have your CEO that comes to you and gives you a new mandate to implement 2 AI projects, and she frames that to you as an existential need. This needs to be done urgently, right here, right now. And the 2 projects are, one, to help the customer purchase process by having a conversational assistant with generative AI, and the other, to improve the customer service with a 24/7 automated agent. Now, your competitors are already doing something like this, hence the characterization, hey, this is an existential project for us to take on. Now, you have a very good handle on what it takes to run the core business. You've done all the sizing. The infrastructure at a peak needs to support 200 million web requests per second with an Nginx server. That results in a bunch of kind of product-oriented queries that you size to be 50 million kind of Java operations directed towards your app server that's built with Java. And that results in a downstream 100 million transactions per second capacity that you need in your MySQL instance. So you've got that sizing done. That's all well buttoned up and laid out. Now, you also size what these 2 projects need for AI. And you come up with an estimate that, hey, you need $3.5 million to kind of get these AI projects implemented. Now, when you think about that, that is fully 25% of your budget. So how in the world are you going to accommodate that when your budget didn't just dramatically increase? That is the conundrum of figuring out how to deploy AI initiatives or any business transformation initiatives within the budget frameworks that each of us work under. Now, the way out of that conundrum is to modernize in a smart way that pays a dividend that you can then use to implement these strategic initiatives. What we are showing here on the left-hand side is that infrastructure that you've sized when it's implemented in M6I, and on the right-hand side is that same infrastructure when it's implemented on M7A. And again, let's just recap that M6I is Intel instance based on Ice Lake. M7A is AMD instance based on 4th-gen EPYC. Now, based on the capacity requirements that you already know very well, you need 2001 M6I instances to deploy that, to support that business footprint that you have. And that takes up $13.5 million. It basically is your budget. It kind of makes sense, right? Your budget is what it is because you've sized it, and it's a run rate business that you have going. One point I want to make here, by the way, all of these calculations are done based on list pricing, but the math is the same, right? If you have a discounted price, it equally affects both sides. So all of these percentages will automatically flow through. Now let's look on the right-hand side with M7A. You're able to do the exact same thing. 200 million requests per second, 50 million Java operations per second, 100 million database transactions per minute, all of that with 1,216 instances, so which is a very significant reduction in the instance footprint that you have from the left to the right. And that translates to 27% cost savings. So you're doing the exact same amount of work, you're supporting your core business with the exact same SLA, serving the same number of customers as before, but you immediately saved 27%. And this quite literally is a push the button. There is no porting required. It's directing from M6I to M7A. Now, if you look at the cost savings associated between the left and right, that's $3.5 million. That $3.5 million you can use to deploy the AI projects that you've already scoped out. Now, that's the advantage of picking and modernizing with 7th gen AMD instances. You get the same amount of work done as before, but you give yourself the room and the flexibility to either realize those cost savings or redeploy those cost savings. I think this is a very straightforward competitive advantage. You modernize with the right technology that gives you great performance, very tangible business benefit that you can either take to the bank, immediately lower your expenditures, or redeploy to drive your business in a more accelerated way. By the way, that can work the flip side as well, right? Your competitors would be doing the same math, and they could deploy something like this, and if you don't, they would have the leg up. So when I stop to think about it, it's almost like the prisoner's dilemma, but the positive version of it, because the choice for you to make is the right choice for both, which is to adopt the right technology that gives you the business benefit that accelerates your business. Now, I walked through the economic value, the performance and the economic value of the instances, and a real-world scenario of how a business can benefit from that economic value. So what are these instances that are delivering this much performance, and how is this performance being realized? So AMD has a full spectrum of 7th gen instances that AWS has released on EC2. So there are 4 families, M7A that I've talked about till now and shown you the performance of. These are the general purpose instances applicable for the broadest set of workloads. R7A, these are applicable for memory intensive workloads. C7A that are optimized for compute, and HPC7A applicable for high performance compute. When AMD and AWS product teams got together to define what should be the characteristics of the 7th gen instances, we had 3 tenets that we were working towards. The first is exceptional generational performance gain from 6th gen to 7th gen. The second is compelling price performance benefit when you go from 2nd gen to 3rd gen. And the third is very seamless push button migration. So those are the 3 tenets that undergird and inform how these instances have been created. AWS made a very strategic pivot in 7th gen instances by turning simultaneous multi-threading off in AMD's 4th gen EPYC CPU. And this is an important point that we should spend a little bit of time on, because it is the driver for the performance. So if you look at the 6th gen instances, your vCPU, the fundamental unit of compute, is a thread. In these 7th gen AMD instances, your fundamental unit of compute is the full core. The combination of AMD and AWS technologies enables AWS to do this. So you have very high core density that we are bringing to the table with extremely performant cores, and with Nitro technology that enables offload of virtualization and other functions. That combination allows for AWS to turn SMT off and offer the full capability of the 4th gen EPYC core in the vCPU. That is the engine that is driving all of the performance that I've been showing in the previous slides. Now let's go through each of these instance families and give a brief overview of what are they good for and what are the design characteristics of these instances. Let's start with M7A. As I said, M7A is the most general purpose instance family. It's the kind of the workhorse of EC2 instances. It's meant for a large class of workloads at the front end, web server, your application, line of business applications, as well as in the back end for medium-sized databases and caching fleets. M7A has 2.2 plus x memory bandwidth per instance compared to M6A generationally, and this is enabled by 4th gen EPYC bringing DDR5 at higher memory speeds to the table. M7A is also SAP NetWeaver certified, so your SAP Business Suite apps can run immediately on M7A instances. M7A supports newer instructions that are in 4th Gen EPYC, specifically AVX 512, VNNI, and bfloat 16. So this opens up new classes of workloads in HPC and AI ML that can be deployed on M7A. And it comes in 12 different sizes, from 1 vCPU all the way to 192 vCPUs. One of the very interesting things about the 7th Gen instance, there is a new .medium instance size, which is 1 CPU that hasn't been there before in x86. And this is very, very nice for DevOps environments. If you're running your compilations, CI loops, and so on, it's perfect Goldilocks instance for DevOps. Gives you very good performance at a very competitive and cost-effective manner. Now, M7A has been adopted. The adoption curve for M7A is very, very healthy. And as you try it out, you will see the benefits that I've just described in the previous slides. And one of the customers, Acciona, they're a multinational conglomerate that focuses on renewable energy and climate change-oriented infrastructure. They've adopted M7A, and they've seen 59% acceleration of their electric grid simulations. So if you think about an infrastructure company like that, 59% acceleration in simulation time is literally 59% acceleration in your core business. And that's an extremely compelling value. Now, when you look at R7A instances, these are similar to M7A, but with twice the memory complement. So 1.5 terabytes of memory at the highest instance size. These instances are suitable for really data-oriented workloads. So your SQL, NoSQL databases, your in-memory databases like Redis, your data analytics like Spark, Hadoop, and Cassandra. These instances are also available in 12 sizes, from 1 vCPU to 192 vCPUs. C7A, these are the compute-optimized instances. Again, similar to M7A, but with half the memory complement. So it's 384 gigabytes of memory at the highest instance size. Now, these instances are good for really where the computationally heavy workloads, so your media and entertainment workloads, your financial services workloads, or anywhere really where the core to memory ratio doesn't need to be as high. And C7A instances are also available in 12 sizes, the same sizes as M7A and R7A. And we also have HPC 7A. These are really more specifically tailored for HPC workloads like computational fluid dynamics, like finite element analysis, your weather modeling, or energy simulations. These deliver extremely strong performance for HPC 7A versus HPC 6A, and they come with 3x the network EFA bandwidth when you look at HPC 7A versus HPC 6A. Now, they are also available in multiple regions in 4 sizes. These are kind of the right size for the HPC kind of workload deployments. And one of the customers that has been trying out HPC 7A is Ferrari, and they're seeing 30% improvement in their CFD simulations, which is, again, if you think about a car company doing CFD and they're doing computational fluid dynamics for really either the design of the vehicle itself and the safety of the vehicle, that accelerates your design process. That gets you essentially get the product done faster. And that's an extremely compelling benefit for a corporation. So what I've done is walk you through the performance of the 7th Gen instances, talked about the economic value of them, the tangible business benefit of them, and describe the instance families that are creating these. Now let's kind of look under the hood and look at what is the engine that's doing all of this. And that's AMD's 4th Gen EPYC processors. So these are codenamed Genoa. Genoa, quite simply, is the best server processor to ever come to market. It packs an incredible amount of technology. It's got 96 Zen 4 cores, all of them manufactured on leading edge 5 nanometer process node. It's got 12 channels of DDR5 memory at 4,800 megatransfers per second. It's got 128 PCIe Gen 5 lanes. It implements CXL 1.1x for memory expansion support. When you take all of that technology and the features, it delivers incredible performance. Head-to-head comparison of Genoa versus Sapphire Rapids, the best Genoa versus best Sapphire Rapids, 80% higher performance. And that's based on spec int rate measure. But that performance advantage translates across the broad spectrum of workloads, whether you're looking at database, data analytics, virtualization, web front end, or floating point heavy applications. Genoa's performance is head and shoulders above Sapphire Rapids. In fact, Genoa has 300 plus performance world records, and the number keeps growing every month that we check in on it. Genoa brings all of this performance with extremely compelling energy savings as well. It is extremely energy efficient. If you use spec power, which is a traditional benchmark to see how much work gets done in a given watt, Genoa is 80% more energy efficient than Sapphire Rapids. And this is a very important point for enterprises to think about, right? Yes, in a cloud infrastructure, you're not directly responsible for the carbon footprint of what you're using. But when you have the notion of embodied carbon, you're looking at end-to-end. The energy footprint of your M7A instance versus the energy footprint of M7I or M6I instance is dramatically lower. And that is a very, very important consideration. Now, if you take this combination of high performance and high energy efficiency, it gives you really compelling TCO. I've talked about kind of TCO in a cloud world is what is your cloud OpEx spend. On an on-prem, it's probably your acquisition cost comes into play as well, and Genoa is a great solution for both of those. Genoa also implements our Infinity Guard security feature set, and that architecture is the foundation for cloud confidential computing. Our Infinity Guard architecture provides security that's 360 degrees. So your memory is encrypted, so your data is protected. Your virtual machine is encrypted. The state of the CPU is encrypted. And in fact, your virtual machine is protected from a malicious hypervisor. If your cloud host or hypervisor is compromised, your virtual machine is protected as well. So with those security features, that's the driver for cloud confidential computing instances that are based on Genoa. And Genoa also comes with a rich and full ecosystem of solutions so our customers can deploy in a turnkey fashion and get to value faster. So this is the engine. And based on this engine, the design choices that AWS and AMD jointly made enables the incredible performance that I've talked about that then drive the business benefit. Now, I've talked to date about the 7th gen instances. They are to the right of this slide, where if you're modernizing based on a performance metric that you're trying to solve for, so if you have performance-oriented workloads, the 7th gen AMD instances are a great fit because they deliver extremely high performance. But you have some applications that may not be performance bound, in which case 6th generation instances, so the M6A, R6A, C6A, and HPC6A are very, very good choices because those instances provide similar performance as the Intel-based instances. So M6I and M6A performance is roughly the same, but M6A is 10 to 45% cheaper. So if you think about an example, let's say a financial services company, they would be running computationally heavy tasks like, let's say, risk or fraud detection, those kinds of analysis. Those fall into the bucket that I've started the talk with, performance-intensive applications. So the high performance of M7A and the 7th gen AMD instances immediately gives you value, so you reduce your instance footprint, drive cost savings. But that same bank will have a bunch of standard IT-oriented workloads like VDI or your Linux and Windows servers and so on. Those are not computationally intensive. So you can pick the 6th generation instances and save money on cost, the pricing of it. These instances are 10 to 45% cheaper. So if you have a performance-hungry workload, those go into the 7th gen instances for modernization to get cost savings through performance. If you have workloads that are not performance sensitive, you deploy them on M6A and 6th gen instances and get cost savings through pricing. So you kind of win both ways. And that's the beauty of the portfolio that we have with AWS, with AMD, where you win when performance is the key metric. You also win when your cost is a key metric. And both places, you're getting cost savings. One just driven through performance that reduces your footprint, the other just straight the bottom line where the reduction of cost. Now, all of this, by the way, is made possible by the close partnership that we have with AWS. AWS and AMD have long-standing collaboration that's deeply embedded and engineering-oriented, where we optimized every level of the cloud stack across multiple generations and multiple years. AWS released our very first first-gen Epic-based instances in 2018. And since then, the growth of AMD-based instances has been exponential. We have now 100 plus AMD-based instances on EC2. 17 or more services from PaaS services from AWS run on AMD instances. So your ECS and EKS, the Elastic MapReduce, and many more of those services are driven. So behind the scenes, they use AMD instances. AMD is part of the ISV Accelerate program, and we offer a full complement of support for customers like you to try to get to a POC and to migrate and adopt these instances. So with that, let me end with a call to action, which is to modernize by making the right choice of picking 7th gen AMD instances that deliver the best technology, the fastest performance, and the most compelling cost savings. If you want to learn more about the detailed workload breakdown, as well as performance briefs, you can scan the QR code on this slide. And we also have another breakout session at 4 p.m. today, where we'll go through each of those boxes. I've given you the detail on one of the workloads. We'll work through the various applications and the performance data, as well as the business benefits that's resulting from that performance.